welcome to the Mempool Masterclass series. My name is Julio, Director of Content and Education here at Blocknative. I have with me Blair Marshall and Emily Case.
Hey guys, I'm Blair. I'm a lead solutions engineer at Blocknative, working on the BD team. I've been with Blocknative for a couple of years now, so happy to be here to talk about simulating transactions.
And I'm Emily. I'm a product manager here at Blocknative, and I will be wrangling the Q&A section.
So this is our third and final course in the Mempool Masterclass series, Simulating Transactions. In this class, we're going to cover the fundamentals of transaction simulations. Then Blair's going to take us hands-on with some code. A heads up, this will be our most technical class in the series. We will be sending out the slides and recording afterwards, so I do recommend you just sit back, relax, and focus on listening and learning. With that said, a little about us. Blair, Emily, and I all work at Blocknative, a real-time Web3 infrastructure company. Here at Blocknative, we have unparalleled visibility into a comprehensive set of mempool data that powers users to see the future, change outcomes, and transact with confidence. We hope that this masterclass is the beginning of the journey for you, and that this is the start of many fruitful conversations. So let's get started. Simulations 101. I like to think of transaction simulations at a very high level as letting you see the future. What's going to happen when my transaction actually makes it on chain? Transaction simulations are often used to unlock profit potential for traders by identifying price or liquidity changes before it hits the chain. So traders can test strategies before ever signing a transaction. Simulations can also help protocols intercept malicious transactions before they get confirmed on chain, or they can even notify users that they're about to have their wallet drained. Lots of use cases for transaction simulations. The way transaction simulations are able to do this is by revealing all of the internal calls that execute inside of a transaction. So these internal calls, or internal transactions, as they're sometimes referred to, refer to the interactions from one smart contract to another. This type of transaction is super widely used within the Ethereum ecosystem, especially as smart contracts become building blocks for more sophisticated interactions. So sometimes a single transaction on a smart contract can result in dozens or even hundreds of internal transactions that interact with either numerous other smart contracts, or they might just distribute value to a host of different wallets. But by revealing what these internal calls, these internal transactions are, you're actually able to identify what's going to happen on chain. Now, just being able to identify these internal transactions is only part of the simulation story. To fully simulate a transaction, you need to run the transaction on the EVM, executing all smart contract method calls with the specific transaction input parameters and a known state tree, right? This known state tree part is super important because it tells it tells the simulation the conditions of the network. You'll likely want the state to be represented by the current chain head, which is essentially the most recently agreed upon state across the network. When you run a simulation this way, it is going to give you an accurate account of how the internal transactions are going to settle under the current conditions of the network. And this gives the user the ability to see some really advantageous data. This includes net balance changes, right? So any net balance changes of liquidity pools before they hit the chain, searchers can use that data to drive any kind of arbitrage strategies, MEV strategies that they might have. You can see expected slippage, right? So traders can use that to either reduce transaction anxiety, or maybe better understand their trades, or even identify when they're at high risk of MEV. You can also determine whether or not you're about to interact with a malicious smart contract, right? Sometimes smart contracts might be designed to drain your wallets. Or it could just be a buggy smart contract that doesn't function the way you expect it to. So you can simulate that smart contract transaction and see that you're going to get an error and have wasted gas fees. You can also test strategies and see how accurately they might play out in the next block. Now, when we're talking about simulating transactions, we can do it either in flight or pre-flight, which is basically just another way of saying we can simulate pending transactions, right? So pending transactions that are already in the mempool, or we can simulate unsigned transactions. So transactions before we even submit them. In this course, Blair is going to walk you through some use cases for both. Finally, I'd like to leave you with transaction simulation is a super powerful technique, but simulating quickly and at scale is a challenge even for the most well-resourced teams. Fortunately, Blocknative does offer some really great real-time battle-tested infrastructure that makes simulations as easy as possible to integrate into either your strategies or your project. And with that, I'll let Blair take it away.
Cool. All right, I'm going to share my screen here. Can everyone see my screen? Good to go. Awesome. So to understand transaction simulations, I think it is helpful to have a little bit of a background on, just regular pending events, regular mempool events, and then how that relates to a simulated event. So I'm going to walk you through our Mempool Explorer. I highly recommend going to explorer.blocknative.com. Mempool Explorer is a great place to author and construct your strategies. You can create filters. You can subscribe to different addresses. It's just a nice, easy to use UI to understand how our Mempool API works. So this is the kind of the home page. Everything you see or everything you do on Mempool Explorer is address based. So you just come in here, type in an address, or you can start following a smart contract. This address can be either your wallet or it can be, some random smart contract that you care about. You can also use the live examples down here or even the videos to help you out. So I'm first going to get started with just watching the Uniswap auto router because it's pretty active and popular. So you can immediately see the stream over here. So I've subscribed to this address and you can see, this is a very active one. We're getting all sorts of events. I'll pause it here. We're getting pending events. We're getting confirmed events. We're getting failed transactions. You'll get everything. And what's nice about Blocknative's platform is everything in our payload is filterable. So for example, if I wanted to add a filter for just looking at pending events, so these are going to be the mempool events, I can easily add that here in the UI. I'll clear this, I'll restart the stream, and now you'll see the stream will be less rapid because we're just getting kind of the pending events instead of all the other types of events. And we'll pause and we'll look at one of these. So this is a pending event on the Uniswap auto router. And one of the key value added services that we do is that we're automatically decoding the input of popular smart contracts like Uniswap, SushiSwap. And so we add this contract call part to the payload. And so you can see the method name, you can see the parameters involved, and we even have, if in the case where it exists, we have subcalls. So Uniswap auto router calls multi-call, which then calls these functions here, and we'll decode these to show exactly what these method names are down here. And so if there's some specific method name that you care about, you can easily filter for just getting multi-call on Uniswap auto router. So how does this relate to pending simulations? So pending simulations, what we're doing is instead of this pending event here, our nodes will pick up this pending event, and we have a cluster of nodes that all they do is simulate transactions. And so we'll take this pending event in real time, we'll run it through our cluster of nodes. It will run through the EVM, and it will give you a slightly different payload, pending simulation payload. And we will take a look at what that looks like. So in this other tab, I have a host of pending simulation payloads. And immediately we can kind of see that there's a little bit of a difference here in the payload. So what's different? The main difference that you'll start to notice is the internal transactions. So Uniswap Auto Router is a good example. It's an interesting one in that it kind of sits on top of Uniswap v2 and Uniswap v3, and it makes a choice based on pricing and liquidity pools to give the user the best pricing for whatever swap they're making. And you can see that in the internal transactions. So you would not be able to see that in just a regular pending event like we were just looking at, but in the internal transactions, you can see how in this example, it is using the Uniswap v3 router 2, and it's making this method name. And you can see the rest of the kind of internal transactions and function calls that it does to kind of get the user the price that it's going to get. And what's nice about this is all of this is also filterable. So if for whatever reason your strategy, you really cared about something in the internal transactions, you can create a filter for internal transactions, contract call, method name, exact input, single. And then you'll just get pending simulated events that have this method name inside the internal transactions. So you can really fine tune and get granular with exactly what kind of data stream you want. So it's specific to your strategy or your use case. But the most important part of our simulations is actually down here in this net balance changes part of the payload. And so what is the net balance changes? The net balance changes is looking at every single address involved in this transaction. And it's showing how all the ERC20 or ERC721s are going to move within that address. And so I'm guessing that this address here is the Uniswap v3 liquidity pool between WETH and DAI. And so this transaction will specifically result in WETH going down by this much in this liquidity pool and DAI going up by this much in this liquidity pool, which is a very powerful feature. I mean, this is exactly the information you want for creating kind of algorithmic bots. And so what you could do is you could watch for some specific liquidity pool and you could watch for large moves in this liquidity pool. And since you see how this is changing, you know that this change is not happening on Uniswap v2 or SushiSwap or some other DEX. And so you know there could be some pricing dislocation there. And then you can make the calculation on the fly, and there's a potential arbitrage opportunity, and you can react based on that. So that's typical. That's the typical kind of trader use case for arbitrage bots. I'm going to pause here. It looks like we are getting some questions in the Q&A, so I'll pause here for questions.
Yeah, we do have questions. Oh, go ahead, Emily.
Okay, I'll read them out. So the two questions we've gotten so far are, do I need to use Mempool Explorer, aka MPEX, or can I simulate programmatically, i.e. via API?
Great question. So what I'm showing here is just a nice visual way to kind of author your strategy. But what you can do a few things. So we allow you to save, what you have authored, what you've constructed, and then you can easily export it. So you'll get the configuration.json file. If you're using JavaScript, you can use the SDK setup file as well. And then you can plop these directly into your program. And if you head over to our docs, you can go to the Mempool SDK and we'll walk through exactly how to use those two files in your program. And it's actually here at the bottom. So this is, taking from Mempool Explorer and plopping it into your program. So you add these two files here, and then you can start receiving those data streams directly through your program and react or create different handlers so that you can react automatically and programmatically. And then the other, which we'll get to in a second, but I'll do a quick answer here, is we also have an endpoint that you can simulate transactions as you please, and that's unsigned transactions. So you can give us either one transaction to our simulate endpoint or a bundle of transactions, and we'll give you the cumulative effect of those events. And then the payload will, I'll go over this again, but the payload will look very similar to this payload that we're looking at here. Any other questions?
I'm going to skip around in order so that people get their questions answered. What is the unit of measurement in the delta field? Is it Wei?
It is Wei. So it's going to be the smallest unit of measurement. And so you'll have to, it'll be dependent on the decimals. So for WETH, for most tokens, I think it's just 18. But for some like USDT, I had a USDT example up here. Yeah, so you can see for USDT, it's a much smaller number, and that's because I believe USDT is 6 or 8, I can't remember. And so, it depends specific to that ERC20. So you have to grab that information either from on-chain or somewhere else. Does that make sense?
Yes, great, thank you. And then final question from the Q&A is, can I simulate transactions from Web3 Onboard?
Oh, another good question. I'll save that one for the end after I do the transaction preview, because that's more related to that one. And then
great. Now I'm going to pass the mic to Julio because he had another question too.
Oh, go ahead.
Yeah, Blair, will Blocknative automatically provide pending simulations for every pending transaction at the TEX?
Yeah, so the way that works is all pending events that we see that have a marketable gas price, we will simulate. So we'll take a look at any sort of pending event that we get. We'll look at the gas price. And if that is, so we have our gas platform, we measure it against our gas platform. If it looks like that's somewhat likely to get on chain in the next block or two, then we'll say yes, and then we'll simulate that. So not necessarily every single event will get simulated, but most that have a marketable gas price. And if they're if that doesn't quite meet your use case, you want to see every single simulated event, then that's where you could easily use the simulate endpoint and grab the pending transaction and then simulate it against our endpoint. And that way you could see the simulated payload for any event that you care about.
Thank you.
Cool. And then the last thing I would just point out is, our infrastructure is geared towards real time. So we look at ourselves as and the use cases as real time use cases. So we're really looking for kind of low latency. And you can see in our simulated events, we have the latency details of when we detected it, when we traced the event, when the trace ended, and then when we dispatched it to my browser here. And that took this one, for this example, it took 72 milliseconds. So we're really focused on providing a real-time use case here for both traders and builders. Okay, so the next thing I wanted to jump over to, which can you guys see this, or am I only sharing my browser?
Only your browser.
Only your browser.
New share. Here we go. Okay, can you see my code editor?
Looking good.
Cool. So don't be intimidated by this. It's just some basic Python. This isn't a Python course. But what I'm doing here is I'm connecting to a quick node to demonstrate our transaction preview, our simulate endpoint. I'm setting up this preview function. So all it's doing is taking some data that I give it, and it's passing it to our simulate endpoint through a post request. And here I'm just doing an example of what that data could look like, or an example transaction that we could simulate. And I am simulating a swap exact ETH function call on the Uniswap v2 router, and I'm building that transaction. But what you'll notice here is in nowhere am I signing the transaction. I'm simply just building it as an unsigned transaction. And this is kind of what the payload looks like when I build it. And then I create the data blob that works with our endpoint, and I preview it. And then this results payload will look very similar to the Mempool Explorer payload that we just looked at. So it'll have internal transactions. It will have it'll have net balance changes, it'll have the contract call, it'll have all those details. But what I'm showing here is in the result, the net balance changes, I'm looking at the, for this specific transaction, the exact the slippage or pricing that will happen on this liquidity pool. So I was making an exchange, a swap between WETH and token. And so by making this swap, I know that, you know, I'm giving the pool this much, and in return, I'm getting this much token. And so how is this useful for builders and traders? So on the builders side, we work with wallets and protocols to provide this endpoint, so that, you know, in the case of kind of like a Uniswap, they could, the user would construct the transaction using the Uniswap UI, and by constructing the transaction, they're essentially creating this data blob here, and then once they they can click a button that says simulate. Once they hit the simulate button, they will get this whole payload. And Uniswap can then construct this beautiful UI to say, like, hey, you're giving me WETH, and this is what you're getting in return, and like this is exactly what you're getting. So instead of showing the kind of the minimum that you think you would get, you can show exactly what you think you would get by making this transaction against the current block state. So it provides just a nicer, richer UI UX experience on swaps. And then for NFT platforms, like Julio was saying in the beginning, it can detect malicious contracts. And so this example is an ERC20, but we also do ERC 721s, NFTs, and it will show exactly which address is gaining that NFT and which address is losing the NFT. And so if you are interacting with some platform and the platform detects that the NFT is going to some address that isn't associated with your account, then they can flag that to you and say, hey, it's going to this address, which doesn't look like your address. Are you sure you want to do this NFT trade? And so it just creates this like extra layer of protection. And that's actually exactly what we work with Ledger on. So they are coming out with their Web3 check. And when you go through a Web3 check, part of that is simulating the event before the customer can actually make the NFT transaction. And so, you know, it just gives that extra assurance to its users that, you know, they're interacting with a valid smart contract. Any questions on that?
Is this a good time to re-ask that Web3 onboard question from earlier?
Definitely. So for those, I'm going to go back to this screen. So for those that are not familiar with Web3 Onboard, really quickly, Web3 Onboard is a wallet connection library. So it's popular among some pretty well-known smart contract or protocol platforms. So when you go to connect your wallet, you hit Connect Wallet, and this is our Web3 Onboard library. It's this modal. So Curve uses Web3 Onboard. It handles both hardware and software wallets, and allows, you know, an easy interaction on their platform. And so we are in the process of building in transaction preview directly into Web3 Onboard. So for the case of Curve, it would be more like that swap example. And Curve could use Web3 Onboard to simulate the event before the user makes it. And then they can provide a little extra protection and a richer UI UX experience directly in Web3 Onboard as a part of our library. Did that answer the question? Happy to do any follow-ups there.
I think that covered it. Thank you so much. Are we ready for another question after that? Okay, cool. Can simulation be used to search for MEV?
Yep, definitely. That is a very popular use case. And so searching MEV. So essentially, I would say 99% of MEV is based on a large move in a liquidity pool. So whether you're going to front run it maliciously or sandwich it or back run it, the more friendly use case, it's based on the liquidity pool moving enough so that the pricing change in that liquidity pool is dislocated from the same liquidity pool in another on another DEX. And so, like going back to this example, this is the DAI WETH liquidity pool, and this DAI WETH liquidity pool exists on many different DEXs. And so when you see this transaction, you know that in Uniswap v3, the DAI WETH liquidity pool is going to move in this direction. And so you can search all the other DEXs in real time to see if there will be, directly after this transaction is executed, there will be an opportunity to bring them back in equilibrium, so to speak. And by doing that, there's typically some profit there by bringing this DEX in equilibrium with another DEX. So this net balance changes is ultimately when a trader is looking for opportunities, they're going to do the net balance changes calculation somewhere. But what Simulation Platform does for you is we're doing that calculation for you in a fast, low latency manner.
Awesome. Thank you so much, Blair. I think that's all the current questions we have.
Cool. Julio, any questions from you?
No, I think we're good and we're right on time. If you let me take the screen real quick.
Yep.
All right, so just to go over some of the benefits, since I know this was a pretty dense masterclass we had here. Transaction previews, or the simulating pre-flight and in-flight transactions, has many benefits for all Web3 users, right? It removes the, at a very high level, removes the uncertainty from Web3 transactions so that you can transact with confidence. Users and traders can benefit it by previewing expected slippage or identifying any malicious or buggy smart contracts. We talked about how searchers can benefit from these transaction simulations by identifying MEV opportunities. Wallets can inform their users of accurate transaction settlement expectations, and dApps can use it to improve their UX and ultimately end up reducing user churn. If this is something you're interested in, you want to get started, you can get started for free. We have our links right here to our Discord, our Twitter, and our Docs page. I want to thank everybody so much for attending. We hope you found new ways to use both our Mempool Explorer and new and interesting ways to start incorporating our simulation platform, our transaction preview, into your trading strategies and projects. We'll be sharing the deck, the recording, and any kind of follow-up materials through the Mempool Masterclass channel on Discord. So make sure you check that out. And with that, I bid you all adieu. Thank you so much.
Yep. Thanks, everyone. And feel free to ping me on Discord if you have any questions about any of this. I'm happy to answer one-on-one as needed.
Have a great day, everybody.
See you guys.
Bye, everybody.